the behavior of economic agents, which we discuss in economics, involve relation between two variables or one variable explained by so many other variables. So there is a need for measuring such relations, and econometrics helps us measuring these economic relations. So with econometrics we can have empirical evidences supporting or invalidating economic theory. So we'll have better insight, complete information, more relevant information about economic relations if we are trained in econometrics and we can apply econometrics in our research. Okay, so today perhaps any research in economics, I'll not say any, but bulk of research in economics and even social science requires very good understanding of econometrics and application of econometrics. Okay, and when we're discussing about econometrics in last class, we discussed that this is basically combination of three areas of knowledge. One is economic theory, statistical tools, and mathematical methods. So combining these three, we'll be basically developing our knowledge of econometrics. Then in terms of use of econometrics, we learned basically there are three important uses. One is econometrics helps in economic measurement, which is critical part of economic relations. And by applying econometrics to our empirical work, we can get many useful feedback for improving theory. And finally, econometrics is critical for forecasting, informed forecasting. Okay, given that many public authorities or individual agents, they take decisions which involves forecasting, having good knowledge of econometrics will help taking better decisions in economics. Okay, so that is what we discussed in the last class, and today I'll be basically developing the econometric model. You might had some feeling of econometric model in last class. We'll build from a mathematical model. From mathematical model, go to econometrics model by adding a stochastic error term, and we'll be discussing about various parts. Given that some of you may not be having econometrics in their BA level, so we'll be starting from very scratch. And first we will discuss about the very simple econometric models, simple regression model, and what are the components of that and other details. Okay, so now I'll open PPT to discuss that. Before that, if anybody has having any doubt from my previous discussion, you may please ask. No? Okay, so then I'll start now. Can you see my PPT?
Yes, sir.
Okay. Right. So this is our syllabus and the nature and scope of econometrics we discussed in the last class. So today, perhaps tomorrow, these two sessions will be discussing about simple regression model. Okay, when I'm talking about simple regression model, as I said in the last class, this will be involving two variables, one dependent variable, one explanatory variable. So we'll discuss first specification of that model. So the beginning, to begin with, we need to know how to specify a model. Okay, once we specify a model, then next thing will be how to estimate the model. Okay, for that we will be using OLS method for estimating, and after estimating, inferences need to be drawn. So before we go to inferences, we'll be discussing about assumptions maybe in the fourth session, and then we'll go to hypothesis testing and goodness of fit for inferences. Okay, right. So first we discussed about a model in the last class. I think a couple of you gave your idea about what is a model, and then I combined that. And we discussed that a model is basically abstraction of reality. Okay, so in the real world, given the relations across economic variables may be very complex. The behavior of various individuals may be very complex. So in model, what we do, we basically try to extract the essential aspect of those economic relations or those economic behavior, and using those simplified essential patterns, okay, we basically construct our model. So this model will be definitely not exactly reflecting the reality, will not include many details, but it will capture some essential part of reality, which will help us in explaining certain economic behavior or pattern. Okay, so we are already familiar with many models like market model. In market model, you have a demand equation, you have a supply equation, and from equilibrium of demand and supply, you derive equilibrium price and equilibrium quantity. And another model which you are very familiar and will be repeatedly using in our discussion for econometrics is the Keynesian psychological law of consumption, which basically suggests that as income increases, consumption increases, and increase in income, increase in consumption will be less than increase in income. So these couple of sentences, which basically explains the individual's consumption behavior according to the Keynesian thinking, okay, can be expressed in the form of equation 1, which you have on your screen. So here, if I denote consumption expenditure by C, I stands for the individual. So CI stands for the consumption expenditure of individual I. Okay, I can be 1, 2, 3. I can be Abhirami, 1 can be Abhirami, 2 can be Akhilesh, and 3, depending, Adora, your serial numbers, your roll numbers in our, class. So the I stands for, say, for a particular student in the class. Okay, so 1 can be Abhirami, 2 can be Adora, as per your, the chronology in which your name appears in the attendance register. Okay, so similarly, YI may be the current income or disposable income of a student, right? Then this equation CI is equal to beta 0 plus beta 1 YI denotes the Keynesian consumption function. Okay, and here we put a restriction that beta 1 is greater than 0, less than 1. Okay, and you might have learned in macroeconomics, beta 0 can be considered as subsistence level of consumption. That is the minimum level of consumption which an individual on an average will have even without any income. That is the minimum consumption expenditure on food and other essentials are required for very survival of the individual. Okay, so this is the Keynesian consumption function expressed in the form of a mathematical model. So equation 1 here is a mathematical model. Okay, now what is the drawback of the mathematical model? Mathematical models suggest that all individuals having a particular income will have same consumption expenditure on an average. That means, on an average is not coming here, sorry. This model will suggest, say, if YI is 10,000 for student 1, and it is also 10,000 for student number 9, it is also 10,000 for student number 21. According to this model, all the 3 students, student number 1, 9, 21, all will have same consumption expenditure, isn't it? This suggests that, say, when YI increasing by, say, 10,000 rupees, and say beta 1 is 0.5, for example, then it suggests that consumption expenditure of all the 3 students, 1, 9, and 21, will increase by 5,000. But all of us know this is not realistic, because even if income increases by same amount by all the 3 students, how much their consumption will increase depends on several other aspects. One aspect could be the individual's nature, motivation towards saving. if one of the student like to, has preferences for more saving, propensity to saving is more, then I think her increase in consumption will be less. If another student whose propensity to save is less, okay, then increase in consumption expenditure will be higher. Okay. Now, if I think in general, I talk about a household. I stands for a household. So CI is the consumption expenditure of household one. YI is household consumption expenditure for individual I. Okay. Sorry, YI is household income. CI is consumption expenditure. I stands for particular household. Okay. So these households may differ in many other aspects. These households may have different family size. One household can have 2 members, another household can have 5 members. Then it depends on, depending on that, increase in consumption expenditure will vary. We'll expect that when the family size is more, increase in consumption for same given increase in income will be more. When family size is less, increase in consumption will be less given the same increase in income. Okay, that intuitively we can think. Then secondly, depending on which locality they live, do they live in a locality where you know uh, generally more affluent people live, or they live in a locality where relatively poor people live? Depending on that, the increase in consumption expenditure will vary for same given increase in income. Okay. Let me give an example. Our consumption pattern varies depending on the locality where we live. So if you're living in a more affluent society, maybe you require some higher standard of living, having automobile, having a car, having air conditioning, and maintaining similar living standard matching to that. Okay, your consumption pattern will be relatively more. And if someone is living relatively poor locality, then the given the standard of living, the consumption pattern will be relatively more moderate and modest. Okay. See, one example I can give you to, of course, all of you understand this, but one example will uh, make this point very clear. See, if I go to work, okay, I go for my morning walk to Pondicherry Gandhi Beach, right? And Gandhi Beach from my home is roughly 3 to 4 kilometers. So, how do I go to Gandhi Beach for morning walk from my home? Generally, I take my motorbike, or sometime I take my car, right? So, if somebody somebody is relatively poor, then he perhaps go in a cycle or use public transport. You'll surprise when we're in Mumbai. I was living in a place called Tardeo, and the race course in Mumbai was very close to my home. So that's again another maybe 2 kilometers from my home. So we used to go to walk with my neighbors. And have you heard of Anil Ambani? Dhirubhai Ambani has two sons, Mukesh Ambani and Anil Ambani. Mukesh Ambani, Reliance Industries, and Anil Ambani also is he owns part of the Reliance empire. So in those days, I think they were living together. So Mukesh Ambani, Anil Ambani also used to come for morning walk. Can you imagine how he was coming? You'll expect he may be coming in a posh car. That is the maximum we can expect. But many times we have seen he used to come in a helicopter. His home may be some 10 kilometers from the race course. Okay. He had option of by coming by car or coming by luxury car maybe, but he was coming in a helicopter. Okay. So, that's how the consumption pattern or expenditure pattern of individuals vary. So depending on your income profile, accordingly you decide how do you go from one place to another, even the distance is short. Okay. So that reflects everywhere. That reflects in your consumption of food, maintaining luxurious living. So across individuals, even income increases by same amount, by how much amount the consumption expenditure will increase, okay, that naturally varies from person to person, household to household, depending on several other factors. And those other factors can be family size, those other factors can be residence of affluent, where the residence lies, whether it is a more of affluent society or relatively poor society. And you can think of so many other factors to explain these variations in increase in consumption due to increase in income by the same amount. Okay, so that way, trying to portray the economic behavior of agents, like here the consumption behavior of households or individuals, in the form of the mathematical model looks oversimplified. Okay, and the predictions which it gives appears to be unrealistic, because the prediction from the mathematical model is increase in consumption will be same for all individuals for who income increases by a particular amount. Like here, income increases by 10,000. Okay. Now, given this shortcoming or limitation of a mathematical model, we have to improve this so that this explains economic behavior in a more realistic way. Okay, so this deterministic model, we call this model as a deterministic model because it is deterministic, telling a fixed increase in income, increase in consumption for a particular amount of increase in income. Okay, so this deterministic model is not very useful to explain economic behavior. So improving upon this mathematical model, we have to develop an econometric model which will be more realistic. Okay. So these variation in individual behavior or response to the same thing, okay, need to be modeled appropriately. So in our model 2 here, which you can see, we have added a new term on the right hand side, which is UI. Okay, and this UI is known as stochastic disturbance term. Okay, now model 2 is a simple econometric model. It is an econometric model because it is improving the mathematical model by including a stochastic error term. So the difference between the mathematical model and the econometric model is addition of this UI here. Okay, which basically captures the randomness or stochastic nature, okay, of the behavior pattern of individuals. Okay, the response of each individual to change in exogenous variable by certain amount is very different. Okay, so even now, when you are given any incentive in the form of increase in income or reduction in interest rate or whatever, for the same amount of incentive, each individuals differ differently, each individual responds differently. Okay, which is basically influenced by several other factors reflecting differences across the individuals. Okay, and these differences, the stochastic nature of these disturbances, the differences is captured by adding UI in the mathematical model, and then we get the econometric model here. Okay, now a couple of nomenclature issues I need to discuss for those students who are new to econometrics. Here the left hand side variable CI has certain technical name. Okay, CI is generally we call it as a dependent variable. It has several names. Okay, one is dependent variable. It is also known as the explained variable. It is also known as the left hand side variable. It is known as the endogenous variable. Okay, it has several names. Okay, generally I'll refer as dependent variable in this course. Okay, CI here, the name of CI is, CI here is consumption expenditure, of course, but in general we'll call that variable which is appearing on the left hand side as dependent variable, explained variable, endogenous variable, etc. Okay, and the economic variable which is appearing on the right hand side, that is yi. Yi here is of course income, current income or disposable income. But yi, any right hand side variable in an econometric model in general is referred as independent variable, explanatory variable, or exogenous variable. Okay, so when we call the left hand side variable as endogenous, we'll call right hand side variable as exogenous. When we call the left hand side variable as dependent variable, we'll call the right hand side variable as independent variable. When we call the left hand side variable as explained variable, we'll call the right hand side variable as explanatory variable. Okay, so we discussed about ci, we discussed about yi. Now let us come to beta 0. What is beta 0? Beta 0 is intercept. All of you know beta 0 is intercept in mathematics. Okay, same interpretation here. It is known as the intercept. And what is beta 1 here? Beta 1 is your slope coefficient. Okay, beta 1 is slope coefficient. So you are now, I mean, though even those who are new, of course, for those who already studied econometrics, for them it is repetition. And for first time, those who are learning econometrics, these are the nomenclatures you remember. The left hand side variable is known as dependent, explained, or endogenous variable. The right hand side variable is known as independent, explanatory, or exogenous variable. Beta 0 and beta 1 are intercept and slope coefficients respectively. Okay, ui is the most important variable which is introduced here, and all of us need to understand very nature and properties of ui. Okay, in fact, your entire learning of econometrics hovers around your understanding of this stochastic error term. Okay, this is very critical. In rest part of econometrics models, which we'll be discussing, various models, assumptions, etc., everywhere you will find our discussion largely focuses on the nature and properties of UI. Okay, so this UI, which is named as stochastic disturbance term or random error term, okay, this is very critical new term which you are learning in econometrics, and this is the most critical component of a econometric model. Okay, if the nature and properties of UI is as per certain criteria, then you can estimate an econometric model which will be very useful to capture the economic relations or explain the economic behavior of your agents. Okay, and that will help you in empirically measuring the economic relations more appropriately. Okay, so for more appropriately measuring the economic behavior using econometrics, the nature and properties of UI need to conform to certain standard patterns, certain assumptions, and certain criteria. Okay, so understanding the properties, understanding the behavior of UI is very critical for you. Okay, so you please focus on this. See, my first couple of lectures I'll be doing, I'll be discussing lots of things where your understanding has to be good. Okay, so listen to me carefully and try to understand the relations, the properties which I'll be discussing in first part of our module 1. Okay, then afterwards, after module 1, you need more of memorizing things than understanding. Okay, but your first module, you need to understand. It is very simple. Okay, but there are certain critical things which even many reputed econometricians have failed to understand. Okay, so it looks simple, but a couple of things are there which is very essential for you to understand. Now, this UI, what it captures, this stochastic error term, what it captures? It basically represents the randomness of the behavior, randomness of individual behavior. Okay, Now, that is, this randomness comes from various aspects. Okay, part of the randomness comes from the random impact of several explanatory variables which are not captured explicitly in the model. See here, in the model 2, we are having only YI, that is disposable income or current income, as one explanatory variable. But all of us will agree, in addition to income, wealth of an individual will also have significant impact on consumption expenditure. So wealth is not included here. Similarly, family size can be one important variable. It is not included here. Taste and preferences of an individual is an important variable. That is not included here. Okay. Now, if I count, there could be many. Okay. But among them, maybe let us assume these three are important variables which should have been included but not included in this model. Okay. So now these variables like say family size, taste and preferences, wealth, there can be an average impact of these three variables. There can be some random impact of these excluded variables. Okay, the random impact of these explanatory variables are captured in UI. Okay, and the average impact of these excluded variable is captured in beta 0. Right now, similarly, there could be some error in the or approximation in the functional form. Say, for example, this relation we are expressing in a linear form, right? The exponent of beta 0 and beta 1, y1, yi, everything is 1. So it is a linear equation. It may happen that the the actually economic relation should be explained as a, say, maybe say exponential function or rectangular hyperbola or logarithmic function. So if actual relation is logarithmic or exponential, but we are trying to estimate a linear equation, then we are basically sort of using a wrong functional form. So any error due to use of this approximation in the functional form, okay, will be reflected in UI. Then thirdly, there could be measurement errors in YI and CI. See, when we are collecting data on consumption expenditure, there could be many measurement error which you might have discussed in statistics. There could be measurement error due to conceptual issues also. Okay, say if this relation actually is valid for permanent consumption and permanent income, but instead of permanent income and permanent consumption, if we are using current income and current consumption to estimate this relation, then of course we are committing a mistake. There is a measurement error conceptually. Okay, and in terms of statistics also, there could be errors in data collection, tabulation, etc., etc. Okay, so all such measurement errors of the dependent variable and explanatory variable are also sort of taken into account in the stochastic error term UI. So this UI term, which looks very simple, actually captures the impact of so many things, as I told. Okay, this captures the random impact of the excluded variables, that impact captures any error in the approximation of the functional form, as well as any measurement or error for the dependent variable and independent variable. Okay, so I think as of now, just remember this much about UI. Now, a couple of things I need to tell about the intercept. Okay, in the intercept, the way you learned in mathematics when you were learning about the consumption function, we interpreted there the intercept is the subsistence level of consumption. And if you are estimating total cost as a function of quantity, maybe your intercept represents the fixed cost. So in several examples in econometric models, your intercept may have a meaningful interpretation in several examples. But there could be many other examples where the constant or the intercept term doesn't have proper interpretation. Okay, so particularly, I'll tell you one thing to remember. If your econometric model doesn't have adequate values of independent variable close to zero, then your intercept may not be very meaningful. For example, the consumption function example which you are telling, if I'm having yi as income of individuals, most of the income of most of the individuals will be in thousands, lakhs. Okay, you will not have any number less than 1,000. Okay, so having value of yi close to zero is almost ruled out. So when this is the case, then the intercept may not have meaningful interpretation. Okay, so this thing you just remember when I'll be explaining with an example. That time I'll basically tell something more about it. So now after specification of the model, we have discussed about specification of model. How we discussed econometric model is basically a mathematical model, added UI to that. So the specification of the simple econometric model is as given in equation number 2, the simple econometric model. Later on, we'll be discussing about a multiple econometric model, multiple variable, multiple regression model, where you will have more than one explanatory variable on the right hand side. You can have, along with current income, you can have wealth, you can have family size, you can have some proxy for test and preferences. So you can include those on the right hand side. So those things will postpone when discussion of multiple regression model to the module 2. Okay, in this module we'll discuss a simple econometric model, and this model is specified as in equation 2. Okay, now all of you are clear about what I discussed about specification of a simple regression model. If anybody is having any doubt, please ask me.
Excuse me, sir.
Yes.
Sir, if beta 1 is equal to 0 and the C is equal to beta 0, then sir, what will that imply about the model?
See, beta 1 can be anything. Okay, beta, see, one thing is, your econometric model and the estimates which you are getting for a particular sample. Okay, theoretically, the econometric model which we are discussing, that is applicable in general, right? So when I'm telling in general, Keynes suggests that beta 1 value will be greater than 0, less than 1. Okay,
Yes,
now
yes.
you may have a sample, maybe you collected information for 100 people and estimated a relation in which you found beta 1 to be 0. Okay,
Yes, sir.
ideally it should not be, because when income is increasing in the human behavior, there will be some increase in consumption, maybe more or less, but no increase in consumption when income increases doesn't appear to be rational. Okay, but in
Yes,
case that is the thing, when beta 1 is 0, what it suggests? It suggests that your consumption pattern is flat. Okay, so your intercept, whatever value for intercept, that is your consumption, right? So when
okay,
we are telling beta 0, beta 1 is equal to 0, what does it mean? It means that there is no response in consumption when there is a change in income. So that will happen when, if I draw a graph where I have y on x-axis and c on y-axis. So this will be given by this line, which is parallel to y. So your consumption is constant, given by which is equal to beta 0, which is equal to intercept. Okay, change in income doesn't have any impact on that. Okay, although in terms of economics, this doesn't appear to be intuitive. Okay, but of course you can have these possibilities, okay, which can be an exception, right? Is it clear?
yes, yes, sir. Thank you, sir.
Any other question, or you want any additional?
Yes, sir.
Yeah.
Sir, as beta 1 is equal to 0, So, sir, in simple econometric model, so, sir, there is any role of stochastic error term, sir?
Well, stochastic error term role will be there. This beta 0, which you will get, that will, of course, I'll be good that you're asking. Anyway, these things I should have discussed afterwards. See, when we're telling beta 0, that represents, in econometric model, that represents consumption expenditure on an average. Okay, see, if my beta 1 is equal to 0, what my model becomes? My model becomes yi, sorry, ci 1. Yeah, you mute your mic. Somebody's mic is making noise. So when my model is ci is equal to beta 0 plus beta 1 y0, sorry, yi plus ui. This is my model. So when beta 1 is equal to 0, this model becomes ci is equal to beta 0 plus ui, right? So beta
Yes, sir.
0 will give what? Beta 0 will give the amount of consumption on an average across the individuals. Okay, you may have 100 individuals in a sample. Okay, so for 100 individuals, I will 1 minute. I think I'll open a new slide, so that will be easy to explain. See, here assume here we are putting individuals now. Okay, and here we are putting consumption expenditure, CI. Somebody's income may be here, consumption may be here, somebody here, somebody here. You know, their consumption pattern vary, right? Individuals consumption pattern vary. Okay, beta 0 will give their average consumption expenditure. Okay, but still UI will be there in the model to explain the variation of these actual values from the average value. So your CI is beta 0 plus UI. UI is basically the difference between the actual value here and the average value of consumption for a particular individual. Okay, so UI will be still there because that will capture the randomness in consumption expenditure of the individuals, and beta 0 will represent average consumption expenditure of the individuals. Is it clear?
Yes, sir, it's clear.
Okay, right. So this one I need to delete. Okay, so after specification of the model, next what we require is estimation, right? You know the values of CI, you know the values of YI. CI here is consumption expenditure, YI is disposable income. So to estimate econometric model, what you require is you need to know what is the value of beta 0 and what is the value of beta 1. Depending on the values of beta 0 and beta 1, you will have a model which will explain the pattern between consumption expenditure and income. Say I have data, say there are total 10 individuals in this society. In the world, say there are total 10 individuals. Okay, and if YI current income, I'm putting an x-axis, CI current consumption expenditure, I'm putting on y-axis, and maybe the for first individual the combination of income and consumption is given here. So this is 0.1. So this much is her income and this much is her consumption, right? So C1 here, Y1 here. Maybe there is individual 2 here. For this individual, here is Y2, sorry. So this is for 2, this is for 1, and here is somewhere is Y C2. So like that you have individual 3, individual 4, individual 5, individual 6, individual 7, individual 8, individual 9, individual 10. So you have 10 points like this. So these 10 points basically explain, I mean, depict the combination of consumption expenditure and income for the 10 individuals who basically live in this world. Assume there are only 10 individuals in this world, and these are consumption and income combinations for these 10 individuals, right? So what in econometric model will be doing, we know the value of CI, we know the value of YI. Now, if we assume certain things about UI, which we'll do little later, by assuming certain things about UI, we will try to fit a line, fit a curve, which will basically best explain the pattern of relation between CI and YI, which are given by these 10 points. Okay. See, one line, I mean, one of you may think that I need different color. I think I'll get it right. 1 minute. I'll keep for the moment, draw, say blue line maybe. So maybe one of you think this is the best way to explain the relation between CI and YI. Another student thinks perhaps this is the best way to explain the relation between CI and YI. A third student may think this is the best way to explain the relation between the CI and YI. There is a scatter plot of CI and YI, and all of us can find a way of explaining the relation between CI and YI, which is represented by these points on the scatter plot. Which one is the best? How to know? Okay, the best one will represent a particular set of values of beta 0 and beta 1. So all these three lines represents different values of beta 0 and beta 1, right? Say for example, say the yellow line have certain values for beta 0 here, beta 0 intercept, and slope. What is slope? Basically, if you draw this angle of this line is theta corresponding to the x-axis, then tan theta is basically the slope. Okay, so you have one set of beta 0 beta 1, which is, let me say, beta 0 y for yellow line and beta 1 y for yellow line. You have another set of beta 0 beta 1, which are given by, say, beta 0 blue and beta 1 blue. A third one, beta 0 r, beta 1 r. You know, all of you, please understand. I know it is simple for many, but there could be some individuals who are not understanding it. Please stop me, because if you don't follow what I'm talking at the beginning, it will become difficult for you to understand what will follow afterwards. So each one of you pay adequate attention and try to understand what I'm explaining. I am explaining this, that maybe in the world there are 10 individuals, and we have collected the consumption income information for these 10 individuals, and we have plotted these combinations of consumption and income for 10 individuals as a scatter plot in front of your screen. Then we try to explain the general relation between CII based on what we see on the scatter plot. Each individual may have different ways of looking at this relationship. Somebody may think that the yellow line is the best way. I mean, maybe yellow line is one of the way to explain the relation between CI and YI. Blue line is the second way. Red line may be the third way. Okay. So these three lines, in fact, there could be infinite lines, right? There could be infinite lines which can be drawn to explain the relation between CI and YI. Some of them will explain the relationship in a better way. Some of them will explain the relation in not so good way. Okay. So you can have different lines, of course, to explain the relation between CI and YI which is given in the scatter plot. But how well we do that depends on which line we are using to explain this, right? So for simplicity, we have considered 3 possible lines, as I said, but in reality, we can have infinite lines. So whether beta 0, beta 1, y, which is basically yellow line, explains the relationship better, or beta 0b, beta 1b, which is blue line, explains this better, or beta 0r and beta 1r explains the relation in a better way. That is need to be ascertained, need to be verified, analyzed. Okay, how to know among them which line explains the pattern between CI and YI in the best possible way. Okay, that is the major task. That is what we undertake under estimation. Under estimation of econometric model, we try to estimate the values of beta 0 and beta 1. That is, we fit a line. See, when we are giving a particular value of beta 0, beta 1, you are basically talking about a particular line. Okay, a particular line represents specific values of beta 0, beta 1. Say beta 0 is 10 and beta 1 is say 0.5, you may be having the red line. Maybe I'm telling. If beta 0 is 100 and beta 1 is maybe 0.4, you may be having blue line. If beta 0 is 110 and beta 1 is say 0.3, you may have the red line. So a particular line here is defined by the value of beta 0 and beta 1. Okay, so this way our task of estimating the econometric model, that is estimating the values of beta 0, beta 1 is next important step. So if we estimate value of beta 0, beta 1 in the best possible way, then we'll say we have estimated our econometric model in the best possible way. Okay. So there are many ways of estimating beta 0, beta 1. In fact, there are many methods are applied, and 2 methods are very popular. One way is method of least squares. In fact, we'll be starting with ordinary least square in this module. In module 1, we'll be using ordinary least square. About ordinary least square, many of you might have certain exposure in your BA level statistics or maybe in PG level statistics, which you undergone last semester. Okay, so we'll be repeating that procedure, that is method of least square or ordinary least square. In simplicity, in simple we call it OLS. Okay, OLS, all of you need to remember. This will be one term in every lecture you'll be hearing 100 times in the econometrics class. Okay, OLS, ordinary least square, is a procedure which will help us to estimate values of best beta 0, beta 1 to explain the relation between CI and YI. Okay, and there is another procedure which is maximum likelihood procedure, which we will not discuss much in your module 1. Last topic we have maximum likelihood procedure, and towards the end in module 5 we'll be discussing certain econometric model, probit model, logit model, etc., where we'll be applying maximum likelihood technique procedure to estimate. So maximum likelihood, the topic of first module, I will not discuss now. I'll discuss everything except that topic. Then I'll go to module 2, module 3, module 4. Module 5, before going to the qualitative dependent variable case, there I will discuss the maximum likelihood technique, and then we'll discuss how to apply those techniques. Okay, so in this course, the estimations techniques which will be an application of estimation techniques which will be discussed mostly of the type of least square procedure. Okay, so is it clear? First, I discussed about the econometric model's specification. We specified a simple econometric model. with a dependent variable, one independent variable, and of course intercept and slope coefficient with the stochastic error term. Now I am telling we will learn the least square procedure, which one of the most popular procedure to estimate an econometric model. Okay, is it clear? Any doubt until now? No questions? Okay. I'll give you a break for 5 minutes. Okay. After 5 minutes, I will come back again. Yeah. Break for 5 minutes. It's 35. I'll come back at 12:40. Are you hearing me, students?
Yes, sir.
Yes,
Yeah.
sir.
Yeah. Yeah. Okay. Come back at 5 minutes after 5 minutes.